Okay, so ready to dive into some option
Oh,
pricing.
guys.
We've got this research paper you sent over all about FIAN,
Yeah.
finance-informed neural network.
Right. Yeah.
So we'll get into all the details, but just for starters,
Sure.
for our listeners, you're no stranger to options.
Of course.
But this deep dive, it's really about, how AI is kind of shaking things up in the world of options pricing.
It is.
What's really interesting to me is how FIAN is kind of trying to bridge the gap
Yeah.
between, those classic financial models like Black-Scholes and the power of,
Right.
machine learning.
That's the really interesting part, because the classic models, like you said, Black-Scholes, they're great, but they have these assumptions that don't always line up
Right.
with the real world, especially
Now. Actually, today, one of the biggest issues is constant volatility, the assumption of constant volatility.
in the real world, volatility
It's all over the place.
is all over the place. Yeah.
And that's where, it gets interesting with those, volatility smiles and skews and things like that.
Yeah.
Those patterns that you see in real market data.
Exactly. And that's what's really beautiful about machine learning.
Yeah,
It can kind of adapt and learn from all of that.
right. It's almost like, how streaming services, like, figure out what movies you want to watch.
That's a great analogy.
Right. They use the data to kind of predict
Yeah.
your tastes. But instead of movies,
Exactly.
it's option prices.
But traditional machine learning can be a bit of a problem because of that black box nature.
Yeah.
You get an answer, but you don't necessarily
You don't know why.
understand why.
Yeah.
Why you get the answer.
It's like, you apply for a loan and they just say no.
Right, exactly.
And you're like, well, why?
Especially in something as complex as finance.
Yeah, exactly.
Yeah. Where there's a lot of risk.
That's where N is trying to step in.
Yeah.
Right. And trying to offer kind of the best of both worlds.
Yeah.
So it's this fusion of a model like Black-Scholes
Yeah.
with the flexibility of machine learning.
Right.
But how does that work?
Well, one of the innovative features of
Yeah.
FinN is that it embeds this principle of dynamic hedging
Okay.
directly into its learning process.
So it's not just passively analyzing data.
Exactly.
It's learning to hedge.
To hedge like a trader would.
That's interesting.
Yeah.
So it's kind of like learning to think about risk.
Yeah, I mean, that's kind of how
That way.
the researchers set this thing up. They took that financial concept
Right.
and put it into the
And baked it in.
baked it into the machine learning model.
Okay. Now that's really cool.
And unlike Black-Scholes, Black-Scholes assumes that stock prices move in a very specific way.
Yeah.
Geometric Brownian motion. MNN doesn't have that constraint.
Okay.
So
No.
it can adapt to different market conditions.
More agile.
Yeah.
Can kind of handle those weird
Yeah.
swings in the market that
Yeah.
throw off these traditional models.
Exactly. And then the question is,
Yeah.
how does it perform?
Right. Don't leave us hanging.
Well, MN
How well does it actually do?
consistently outperforms the traditional methods,
Right.
especially in these really complex scenarios.
So in those situations where Black-Scholes starts to fall apart a little bit.
Right.
Okay.
Where volatility is fluctuating, the Heston model.
Okay.
And not only that,
Yeah.
it's really accurate at calculating the Greeks.
Ah, the Greeks.
Yeah.
Any options trader knows those.
Right.
Those are important.
They're crucial.
So it's not just good in theory. It's showing that it has
Yeah, showing real world
real world applicability.
applicability. So before we get into all the technical details, I want to come back to this idea of delta hedging.
Okay, yeah.
So FIAN uses
Ain't just that.
to delta, which measures how much the option price changes when the underlying asset changes
Right.
to determine how to hedge.
Right.
So
It's almost like
it figures out how to
it's like a sailor, adjusting their sails
Seriously.
to navigate
Exactly.
changing winds.
But it takes it a step further
Yeah.
with delta gamma hedging,
Delta gamma. Now that sounds like we're getting
which is
closer.
a more complex hedging strategy.
Yeah.
Gamma helps you.
So what is gamma? What does that tell us?
Well, it tells you how much the delta will change
Okay.
as the underlying price changes.
Okay.
So it helps you manage kind of the curvature.
So it's not just like the direction.
Right.
It's kind of like the curve
The curve.
in the road ahead.
Exactly.
Okay. So it can handle all this. That's pretty impressive.
It is.
But I have to ask, if it's so good,
Yeah.
why isn't everybody using this? What's
Yeah.
the holdup?
Well, that's a great question.
Yeah.
And that brings us into this evolving landscape of finance.
Yeah.
I mean, this is really exciting,
Yeah.
but it's also a little bit daunting.
Exciting because of the possibilities.
A possibility.
Daunting because we don't know.
Yeah.
So what kind of questions does this raise
Well,
about the future of finance?
how much should we rely on these AI-powered tools?
And what are the downsides?
And what are the downsides?
Yeah. Okay, those are good questions.
Those are questions.
Those are some big
that we'll get into.
questions.
Yeah.
All right, well, let's take a quick break.
Sure.
And we'll come back and we'll keep diving into this FNN.
Sounds good.
All right, so we've talked about how well FNN performs, especially compared to those, traditional models. But I want to peek under the hood. How is this thing actually built? What makes it tick?
Well, at its core, FNN is a type of neural network, which is a really powerful tool in machine learning that can learn these complex patterns from data.
I've heard of neural networks, but how do you teach a neural network to price options?
Right. That's where the training process comes in.
Okay.
And this is where it gets really clever. Because remember how we talked about dynamic hedging being fundamental to the Black-Scholes model?
Yeah.
MNN actually incorporates that principle directly into his learning process.
So it's not just like learning from historical prices, it's like learning how to hedge, like a real...
Exactly. The researchers were very clever in how they translated this financial concept into a mathematical objective that guides the neural network's training.
So it's almost like they've given it this financial instinct, so to speak. But what data does it actually learn from?
So the researchers tested FIN on two main types of data.
Okay.
One was simulated data based on established financial models, and the other was real-world market data.
Oh, okay. So it gets...
Because it gets a taste.
The taste of both worlds.
Of both. So let's talk about the simulated data first.
Okay.
For the simulated data, they used two models, geometric Brownian motion, GBM, and the Heston model. Okay. GBM is a simpler model that assumes constant volatility.
Which we know is not.
While the Heston model is more complex.
Yeah.
And it incorporates what we call stochastic volatility.
Right, so that's more...
Which means volatility that changes randomly over time.
Yeah, so that's how markets actually...
Exactly. So they feed FIN all this simulated data, along with inputs like the current stock price, the strike price, the time to maturity, all of these factors that you would use. The
key ingredients.
To price an option.
Right.
And then FIN takes all this information, crunches the numbers, and then spits out a predicted option price along with the optimal hedging strategy.
So it's learning by doing.
Essentially, yes.
Okay. And how did it do?
The results were pretty remarkable.
Okay.
Especially in the more complex scenarios using the Heston model with stochastic volatility. FN consistently outperformed the traditional methods.
So it's not just like keeping up, it's like exceeding expectations.
Exactly.
Especially when things get a little messy.
Things get a little messy.
Okay. And how about those Greeks?
Right. FN was extremely accurate in calculating the Greeks, which, as you know, are very important for managing risk.
Yeah, that's a big deal.
In the real world.
It means it's not just a theoretical thing. It's like actually real-world applicability.
But I gotta admit, I'm still a little wary of these, like, black box
models. Even if it's doing well, isn't there some risk of relying too much on something we don't really understand?
You raise a very important point.
Yeah.
And it's a concern shared by a lot of people in the finance world.
Right. Because it's almost like, you're blindly trusting your GPS to get you through a new city.
Right.
You kind of want to know why.
You want to know
it's taking you that way.
It's making those recommendations.
Right. Exactly. So how do we address that like tension between the power of it and the need to like understand it?
Well, it's a very multifaceted challenge, but I think there are a few key things we need to focus on.
Okay.
First, we need to push for more transparency in these AI models.
So instead of accepting the black box, we're trying to like...
Peek inside.
Okay. See what's going on.
But then, transparency is only part of it.
Right.
Right? We also need people who can like actually interpret
what they're seeing.
So education is crucial.
Yeah.
We need to equip ourselves with the technical skills to build AI and use AI, but also the critical thinking skills to understand
the limitations
and the potential pitfalls.
So it's not just the like the tech wizards, it's also people who can like bridge that gap
Right.
between, the technical world and the real world.
We need collaboration between AI experts, financial professionals, regulators,
Yeah.
even ethicists,
Wow.
to make sure these tools are used responsibly.
It's almost like we need a whole new way
Yeah.
of thinking about finance
Yeah.
in the age of AI.
You're exactly right.
Okay.
It's not about...
So we've really gotten into like the details of how it works.
Right.
But if we zoom out a little bit,
Yeah.
what are the big implications for finance as a whole?
Well, that's where things get really interesting.
Okay, so we've really been digging into how AI is shaking things up in finance, especially with NN and, all its potential for pricing options and managing risk. But I want to go back to something you mentioned earlier, that idea of the black box.
Right.
And, how much we really understand what's happening inside these complex systems.
Yeah, it's a fundamental question. What does it mean
Right.
to understand something?
Yeah, because we can have a model like Black-Scholes, right?
Right.
That gives us a good estimate.
Right.
But does that mean we really get why an option is priced that way? Or are we just kind of like plugging numbers into a formula?
Exactly. And it raises even more questions when we start looking at something like NN.
Right.
It can learn from data. It can make these incredibly accurate predictions.
Yeah.
It can even incorporate those sophisticated hedging strategies.
Right.
But we still don't always know why it makes the choices it does.
So we're left with this like tension.
Right.
On the one hand, we have this powerful tool that seems to work really well.
Right.
On the other hand, there's this like element of mystery.
Right.
This lack of understanding.
Yeah.
Like, can we truly say we understand something?
Right.
If we can't really explain how we know it?
Right.
Is it enough to just have a model that gives us the right answer?
Right.
Even if we don't get
Right.
the inner workings.
And I think in finance, where results are everything, some people might say, well, as long as the AI is making money, who cares how it works?
Right.
But I think that's a dangerous road to go down.
Yeah.
If we become too reliant on these black box models without really trying to understand them, we risk making decisions without really understanding the potential consequences.
It's like taking advice from some financial guru and not really understanding like their reasoning or their biases.
Exactly. And then the potential for unintended consequences just grows
Right.
as these systems get more complex and more integrated into our financial systems.
Right. Imagine some algorithm, makes a split-second decision to trade something.
Right.
And it triggers like a market crash.
Yeah.
And nobody can explain why it did that.
And nobody can
explain it.
Yeah.
Yeah.
So how do we address this?
Well, it's a multifaceted challenge, but I think there are a few key things we need to focus on.
Okay.
First, we need to push for more transparency in these models.
So instead of just accepting the black box, we're trying to find a way to peek inside.
Peek inside.
And see what's going on. Exactly. We need to develop techniques that allow us to understand how they're arriving at their conclusions.
Okay. But, transparency is only part of it. We also need people who can actually interpret what they're seeing.
Absolutely. And that's why education is so crucial.
Right.
We need to equip ourselves not just with the technical skills to build and use AI, but with those critical thinking skills to understand its limitations, the potential pitfalls.
So it's not just about the tech wizards. It's about having people who can kind of bridge that gap.
Right. We need collaboration between AI experts, financial professionals, regulators, even ethicists.
It's almost like we need a whole new way of thinking about finance in this age of AI.
Yeah, I think you're right.
So as we wrap up this deep dive into AI and finance, what's a key takeaway? What should our listener thinking about?
The most important thing is to stay curious.
Okay.
To keep asking questions.
Yeah.
And to never stop learning.
Okay.
AI is a powerful tool.
Yeah.
But it's just that. It's a tool.
Right.
It's up to us to use it wisely.
Yeah.
And responsibly.
Great advice. Well, on that note, I think we're going to wrap things up. As always, we encourage you to keep learning, keep exploring, and keep diving deep. Until next time.